Alright guys, this is our video lesson for 10-1, Simplifying Radical Expressions. Alright, so we're going to start out this section with some definitions. Starting here with the definition of a radical sign. This is pretty simple. A radical sign is just another name for the square root sign, or the square root symbol. So radical is just another name for the square root symbol. So the radical sign, the square root symbol, means the same thing. Alright? So our next one here is radical expression. And again, this should be pretty simple. A radical expression is simply an expression that contains a radical sign. So, an expression that contains a radical sign. If you look down here, for instance, at number 2, square root of 12 would be considered a radical expression. Or number 3, the square root of 90 would be considered a radical expression. It's just a problem that contains a radical sign. Now, we'll get into problems that are much more, advanced than this. Things like, instead of over here on number 3, the square root of 90, we might have 2 square root of 90 plus, 6 square root of 4 times the square root of 2. Again, that would be considered a radical expression. Again, just a problem that involves radical signs. Okay, and our last one here, the radicand. And the radicand is the expression that is under the radical sign. The expression that is under the radical sign. So again, if we look at our example number 2 here, the expression is the square root of 12, but if I asked you what is the radicand, you would say just 12. 12 is just the part underneath the radical sign. Or on number 3, if I said what's the radicand, you would just say 90. The expression is the square root of 90. The radicand is just the part underneath the radical sign. That will become much more important in later sections, understanding what the radicand is. All right, so get those definitions down, and then we will move on to how to simplify these expressions, these radical expressions. Okay, this is actually a pretty easy section. It's helpful if you remember those perfect squares that I told you should memorize, perfect squares such as 4, 9, 16, 25. That'll make things a little bit easier. I'm actually going to show you 2 different ways you can go about doing these problems. Whichever method you decide you like best is up to you. It doesn't really matter to me. Square root of 100, square root of 100. Hopefully, you recognize that as one of your perfect squares and say the square root of 100 is just 10. And that is correct. Square root of 100 is 10. And that'll bring me to my first method of factoring here. You could say that the square root of 100 is 10 times 10. If you're thinking about like your factor tree, you could say, well, I'm just going to factor the number 100 and say that it's 10 times 10. Well, that means 10 squared, right? And the square root of 10 squared would be just 10, right? Because square roots and squares cancel out, so your answer is just 10. Again, more than likely you just remembered that as a perfect square trinomial. Or I'm sorry, hopefully you just recognize the square root of 100 as a perfect square, and it's just 10. So let's look at number 12. Now, first of all, make sure you do not just type the square root of 12 into your calculator and say that this is equal to 3.46410, so on. That is rounding your radical off. That's giving me a decimal approximation. That is not simplifying your radical, which is what we're not doing. We are not going to give us the decimal answer here. We are just going to simplify this using square roots. Now, the first method here I'm going to show you, which is usually the method I use, but again, this is the easiest only if you know your perfect squares. I'm going to say, okay, I'm going to break square root of 12 into the square root of something times the square root of something. And I'm going to make one of these a perfect square. I want to make one of these two things a perfect square. Well, I say, okay, well, square roots multiply just like regular numbers do. So the square root of 12 could be thought of as the square root of 4 times the square root of 3. Square root of 4 times the square root of 3 does give me the square root of 12. And because of that, I can say, well, the square root of 4 is a perfect square. That's 2. The square root of 3 is not a perfect square, so it stays as is. And since I cannot break the square root of 3 down any farther, you're just done right here. 2 root 3 is your answer. So that would be the first method of simplifying radicals, is just to break them into perfect squares. Now, the other method, and I think that you guys might prefer this method because you don't need to know your perfect squares as well, is to simply break down the number 12, the radicand, the 12, using your factor tree, your prime factorization. Say 2 times 6. 6 is 2 times 3. Circle those prime numbers like we did when we were prime factorizing, and then say, okay, for every pair, for instance, this pair right here, 2 and 2, that would be thought of as 2 squared, right? And the square root of 2 squared comes outside the radical as a 2, right? 2 squared comes out as 2 because the square root of 2 squared is 2, or the square root of 4 is 2. So in other words, anytime you get a pair like this, you bring that pair out as just one of the numbers. Anything that did not have a pair stays on the inside. So 2 root 3, we get the same answer, either method you choose. Okay, so 90, square root of 90, let's look at this one. And this one I'm going to use that second method I showed you with the factor tree, because again, maybe you're not real good with your perfect squares. And I'm going to say, okay, 90. Well, I'm going to break that down into, let's say, 2 and 45. Circle my 2. 45, I'm going to break down into 5 and 9. And 9 I'm going to break down into 3 and 3. So again, what you're doing here is you're looking for pairs. Well, here's a pair of 3s, 3 and 3. 3 and 3 is 3 squared, or 9, and the square root of 9 is 3. So this pair of 3s comes outside the radical as just a 3. The 2 and the 5 did not have pairs, so they stay on the inside. They do get multiplied, so you end up here with 3 root 10 as your final answer. Again, if you're curious, the other method, square root of 90, I would have said, I'm going to break that into the square root of 9 times the square root of 10, because the square root of 9 is a perfect square. It becomes 3 root 10. And then I would say, well, the square root of 10, I could say, is the square root of 2 times the square root of 5, but since neither of those are perfect squares, that doesn't help me break the square root of 10 down any farther, so you're just done there. Again, whichever method you prefer is up to you. I think most are going to prefer the factor tree simply because when the numbers get bigger, it might be easier. For instance, number 4 here. Let's break down number 4. 160, 2 and 80. Circle my 2, 80, 2 and 40. Circle my 2, 40, 2 and 20, 20, 2 and 10. 10 is 2 and 5. So there I got my prime factorization tree. So to now simplify the square root of 160, I simply got to figure out what goes on the outside out here and what stays on the inside, and I do that by taking my pairs. Here's a pair of 2's, comes out there as a 2. Here's another pair of 2's, so that's going to also come out there as a 2. And then here's a 2 and a 5 that did not have pairs, so that stays on the inside. And what do you do with the numbers when they're right next to each other? You multiply them. So final answer here, 4 root 10. So hopefully you're getting the hang of this. I'd like you to try the last two on your own by pausing the video and then coming back and checking your answers. Alright, here we go. 72. Square root of 72. Let's see. Let's do something a little bit different with 72. Let's break it down. Let's say it's 4 times 18. 4 then is 2 times 2. 18 is 2 times 9. My 2's get circled. My 9 gets broken down into 3 times 3. And now I pull my pairs out and leave my non-pairs in. So there's a pair of 2's, comes out as a 2. There's a pair of 3's, comes out as a 3. The only thing that was not paired was a 2. So final answer here. 2 times 3 is 6 root 2. 6 square root of 2. Final answer. Alright, and last problem. Square root of 450. Again, kind of a big one. Let's break it down a little bit easier here. Let's say 45 times 10. Break down the 45 as 5 times 9. 5 is a perfect square. 9 is not. 9 is 3 times 3. I'm sorry, I said perfect square. 5 is not a perfect square. 5 is a prime number. 9 is not prime. It breaks down into 3 times 3. 10 is not prime. It breaks down to 2 times 5. The 2 and the 5 are both prime. So, excuse me. Again, let's look for pairs. Here's going to be my answer, square root of something. Here's a pair of 3's, so it's going to come out here as a 3. Here is a pair of 5's, so it's going to come out as a 5. So I have 3 times 5 on the outside. And then the only thing that was circled that was left over was this 2 right here, so it stays on the inside, giving me a final answer of 15 root 2. So that's it. That's simplifying radicals. That's really all we're doing in this section, except that you are also reviewing what perfect squared trinomials are. So you might need to go back to your Unit 9 notes and review perfect squared trinomials. We'll obviously be doing all of this in class. So there's your notes. Go ahead and move on to assignment 1.